This last question also contains angles that aren't exactly in the diagram, but if I was to draw it and try doing this question the same way that the previous question, I wouldn't find it worked as nicely. So I'm going to show you another method that is open for you to try sometimes. And before I begin doing that method, I want you to think about something for a second. If I tell you that this is a right angle right here, it's a nice corner, and I divide this into a part where there's 36 degrees up here, and 36 degrees obviously is from here to here. If I want to find out how big that angle is, I would go 90 minus 36, and I would get 54 degrees. So this angle here would be 54 degrees. Likewise, if I had the same right angle, and I instead took a piece out of the top that was 47 degrees, this bottom piece here would be 90 minus 47, which would be 43 degrees. This is going to be useful information in a moment. Now, in this question here, it says this diagram shows a falcon on a tree with a squirrel and a chipmunk. Obviously, you don't see a falcon, a squirrel, or a chipmunk, but you see letters that identify with the right shape. So what you have is you have a tree right here, and on the top of the tree you have a falcon. So there's your bird, and the bird looks down at an angle of depression of 36 degrees, which takes me to this line right here, and he sees the squirrel. And if he looks further down at an angle of depression of 47 degrees, he sees a chipmunk. And the question says, how far apart are the animals on the ground to the nearest tenth of a meter? So I'm actually looking for this distance right here. Now, if I was to use the trick I did last time, where I drew my triangle up, it doesn't work as well because I want this little distance here, which is a little harder to show on top here. So instead of doing that, I'm going to take a look at, first of all, this triangle here. But to do that, I'm going to draw this top dotted line. So I have this top dotted line, and then I have the line going down, and then I have this here. And I'm first of all going to look at the 36 degrees. So if I go down 36 degrees, I'm going to have this situation right here. And what I have down here is I have a right angle. And obviously we decided that if this is 36 degrees here, that this is 54. So I'm going to go with this 54 degree angle, my triangle. And the 36 is really just going to get ignored for now. What I know though is that the falcon was 15 meters above the ground. And this bottom line is GS, just so you know. And so that GS, I'm going to call it X, and it goes all the way to there. Let's make our variable list on the side. What do we have? We have a 54, we have a 15, and we have an X. 54 is my angle, the 15 is my adjacent, and the X is my opposite. And obviously I'm using tan again. Tan of A is equal to the opposite over the adjacent sides. The tan of 54, because 54 is the one in my triangle, is equal to X over 15. The tan of 54 is equal to 1.3764 is equal to X over 15. Let's put this over 1. Cross multiply. 1 times X is equal to 15 times 1.3764, and X is equal to 20.6. And again, I was asked originally in my question, if you look above, to find my answer to a tenth of a meter. So I'm going to do that right away, and X is 20.6. Now I'm going to look at the second triangle. Now the second triangle is the triangle that's actually just this one right here. So drawing that one, Also drawing the dotted line on the top. This triangle goes down 47 degrees on the outside, which we found to be 43 degrees on the inside. This is a right angle, this is 15. So let's just draw a line here so we don't get mixed up. You have a 43, you have a 15, and this time, let's go back up to our diagram, and let's call this little piece from there to there y. So here's y. 43 is my angle, 15 is my adjacent, and y is my opposite. The formula is still tan. Tan of A is equal to the opposite over the adjacent. The tan of 43 is equal to y over 15. The tan of 43 is 0.9325 is equal to y over 15. Putting this over 1, let's cross multiply. Y is equal to 15 times 0.9325. And to the nearest tenth, y will be 14.0 when you round correctly. Now the question is, how long is this line right here? Well, what I know is that from here to here, all the way is 20.6. This part of it is 14. To find out this part then, I'm going to take 20.6 minus 14. Now that's distance CS, so I'm actually going to call it CS here. So, breaking that off, CS is equal to 20.6 minus 14, which is going to be 6.6 meters. And that is my final answer.